Today we are going to do partial fractions. Now partial fractions is something that requires a lot of patience, okay? So please round up enough patience somewhere so that we can tackle this subject properly. First, let's do this. We have done this before, okay? How would you add two fractions like this? Well, what you do is you take the common denominator, which is this thing times that. So what we have is write down the common denominator here, which is x minus 3 times x plus 2. And then this part then becomes, you add to x plus 2 here, 2 times x plus 2. And then this part, it becomes minus 1 x minus 3. And then, so that this then, so this, what we started with, will end up with this. Now, if you either cancel this out, okay, this part of the fraction will go back to being that, and this part of the fraction, this will cancel with this, and this part of the fraction will go back to being this. So that is how this this works. And then eventually we will sum up some terms. We have x minus 3 times x plus 2. And then this stuff is 2x. There's minus x, so we have x left. And then that's 2 times 2, 4. And then minus is plus 3, so it should be plus 7. And that is what this becomes when we get this done. And sometimes we might even multiply this part out, and that will give us this. So x plus 7 equals to x squared minus x, okay, minus 3 plus 2, that's minus 1, and then minus 6. And that would be the answer of turning this into one fraction. So that we've done that before. Now, what we're going to do now is the opposite. We're going to be given this thing, and you have to take this thing apart so that it looks like that. And why are we doing that? I mean, we went through a lot of work putting it together, right? But sometimes, sometimes taking it apart is actually useful in certain situations. And well, in one situation that I know of in calculus, and that I was able to use this, and it was very useful because I wouldn't know how else to solve the problem without it. So that's why we have to learn how to take this thing apart and make this go back to that, which is going to be very tedious. Okay, so please have enough patience to do it, and it's important that you learn how to learn how to do it. It's the skill that matters. Once it's done, you do not imagine that, oh no, algebra, I'm just stuck with doing this stuff all the time. It's not like that, because there are actually calculators that you can enter this thing and it'll spit this thing out right away. Or if you can enter this and it'll spit this out. The purpose of us doing it is just so that we get good at it, so that we know how it's done. And those skills are going to be very useful. The skills themselves, not the partial fractions, but the skills of manipulating equations is something that's absolutely necessary for later math. So let's, having said that, let's consider doing example 1 on page 726. So let's look at example 1 on page 726. We have this fraction, okay, it looks average enough. But we have to break it down into two chunks so that it looks something like this, okay? Where you have something over x plus 2, and then something else over x minus 1. And this, we don't know what it is, so we'll call this one A and this one B. And A and B are numbers, but we don't know what they are, okay? And we think that it's likely that this can be broken down into this kind of thing. So, so how are we going to go about doing that? Well, the way we do it is we will do it as if we are adding it together and then make things fit. Basically, we force it to fit until things come out like this. We'll do what we just did. Okay, we'll put them as a common factor, which means we have x plus 2 times x minus 1, and then the first term will be multiplied by x minus 1. Okay, you always multiply the other guy because both guys are multiplying by the other denominator. That way, if you cancel it out, this is exactly this thing. And similarly, we do the same thing here. B times the denominator on the other side. The other guy is the denominator. So then we have, for these two equations to be the same, we'll call this, it's not an equation, this is maybe you call it a term. Well, whatever it is, for these two things to be the same, then the 3x, the numerator has to be the same. That is, 3x had better be equal to ax minus a. I'll multiply this out, plus bx plus 2b. And then we'll line it up piece by piece. That is, we'll rewrite this thing, okay? This is the same as 3x plus 0, being that there's nothing else there. So this is ax plus bx equal to ax plus bx, and then plus minus a plus 2b. Now at this point, we are going to say that, bx. Okay, now at this point, we'll say that if we force a plus b equal to 3, okay, we're going to force it. That is, we'll say that a plus b will be equal to 3. Because we're going to make it that way. That way, we can force this thing to be identical to this one. So a plus b, which is the number in front of x, will be forced to be equal to 3. And then the minus a plus 2b, a plus 2b is going to be forced to become 0. Now, at that rate, then we will, if we can find a and b that satisfy this condition, then we will be able to come up with this equation. So for that to happen, this is an a here. So then from this equation, we get a equals to 2b. Put a on the other side. So a equals to 2b. Okay, and then we'll plug it in here. Put a in this equation. We have 2b plus b equals to 3, which means b equals to 1. And then a equals to 2b, so a equal to 2. So therefore, if we replace a with 2 and b with 1 here, then this thing got decomposed. So the answer is that it will just plug in a equal to 1 in this equation, and b equal to 2 in this not equation, it's called a term or something. Well, expression maybe, yeah. I think it's maybe called expression. Whatever it's called, we're going to replace b with 2 because that's what it will work. Because as we have figured out, if you replace it, then the numbers will come out exactly the same. So this thing, you can take it apart and become these two fractions. And that's what we're going to be doing in this chapter, okay? I mean, in this section. Now, this is an easy problem. Things can get quite challenging, not as in difficult to think of or understand, but difficult to swallow, okay? But if you allow yourself enough patience and, hit this thing until you can pound it flat, then we'll be done with it, and then we'll do something else. Because once you understand how this is done, you can just use a calculator to do it. So we're not stuck with doing this stuff forever. So next, let me erase the board. Next, let's look at example 2, where we have this thing right here, okay? Now, these things are getting worse because the previous example, our stuff was at least factored for us. Well, this isn't factored for us, so that means we have to factor ourselves. Now, the denominator, just the denominator, will factor into, it's still nice in the sense that it has an x in each spot. So to factor the denominator, I'll write down d here, okay? The denominator factors into x times x squared minus 4x plus 4. That is a well-known thing. That's the same as x times x minus 2 squared. Okay. Now that follows the formula that I just erased up there for more space. But I will write it back. Okay. This is the same as the formula a minus b squared is equal to a squared minus 2ab and then plus b squared. This is the exact formula where with a equal to x and b equal to 2, and you follow this formula, and that's how that got turned into that. And similar here. So, well, now that we factor that, what are we going to do with it? Now this thing is going to, we can decompose it, and this will decompose it into something like this. And you have to remember this part a little bit. It's not a lot to remember, but you do have to remember it. So this will decompose in the first over the x term, and that's fine. And second over a different number over the x minus 2, okay? And that's fine. And then yet a third number that will be over x minus 2 squared. So because it has a squared, you have to arrange for two of these things. So, which means there is more work for you. And then, well, but there is no way around it. We just have to do this and then hope that this comes out. This doesn't necessarily even always work. But that is, sometimes you can't find A, B, or C. They don't exist or something like that. But in this case, let's hope that this the example we do exist, and we're not doing this for nothing. So let's, and so we're going to do the same trick as we did before. That is, we're going to multiply stuff together, okay? And then it will be, something will come of it. So this, for this equation then, this part here will be equal to, every single term here will multiply with each denominator that's not with it, okay? That is, we'll multiply everybody, the A, B, or C will multiply other people's denominators. So we have, so this is just the numerator. I'll write down numerator, okay? So the numerator, it will be equal to A times x minus 2. Let's see. It only has to multiply by x minus 2 squared, because it already has this one. Because we're dividing everything by, let's see. Okay, so then it's not the numerator anymore. It's the whole thing. All right. So then, so this equation then, we'll write it over here. So it goes over here. All right. So the denominator is this thing right here, and we'll write it in fraction form, which is x times x minus 2 squared. So this part, to be consistent, this part only has to multiply, A only has to multiply x minus 2 squared to have the common denominator. In the meantime, B is going to need x and x minus 2. So B will multiply by x and x minus 2. And then C will need to multiply by x and x minus 2. Is that right? It just figure out when we cancel this stuff, okay, then once you cancel it, what you have left had better be this thing. Yeah, it looks right. So, and then C only has to multiply by x, because C already, because when you cancel it, then C will be left with x minus 2 squared like it had before. So everything will cancel back to its original form. This one will cancel to be that, and the bx x minus 2 will cancel with just one x minus 2, and cx will cancel with x minus 2 squared on the bottom. All right, so that should be good. And then continuing, now we only look at the numerator of this thing, okay? That way we don't do so much writing this stuff all the time. So let's copy this whole thing out. That is, multiply this whole thing out. We have then ax squared, and then that is minus 2 is minus 4 ax, and then plus 4 a, right? Okay, plus bx squared minus 2bx, you can see this is very error prone for me. and then plus cx. And what does that equal to? Now we need to round up all the stuff, okay? That is x squared has to be rounded up, and x and all that. So the numerator continuing is going to be x squared. What's x squared? A plus b. As I found a plus b is which forms the coefficient for x squared. Next, what about x? Minus 4a minus 2b. All right, plus minus 4a minus 2b, and that's for x. No, there's a plus c here I missed. There's a plus c. Let's not forget the plus c. Okay, let's do a minus 2b and then plus c. That's x. And then are there any numbers? There's plus 4a, and I think that's it. Okay, so plus 4a. Okay, so that should do it. And this thing has to be equal to this. Okay, this thing right here. That is the original numerator, and this had better be exactly the same as that. That is, a plus b has to be the minus 1. Minus 4b minus 2b, minus 4a minus 2b plus c had better be positive 2. And the last 4a needs to be 4. And we'll start with that. Now, let me check first. Well, so far things are looking pretty decent. I got 4a equals to 4. Okay, so then we have 4a equals to 4. That means a equals to 1. And then next, a plus b equals to minus 1, so I'll write that down. A plus b equals to minus 1. That means b equals to minus 2, because a is 1. B equals to minus 2. All right, so we got 2 of them down. We're doing great. And finally, where's c? This thing right here equals to 2, okay? Let's see, minus 4a, let's see, minus 2b plus c is equal to, right here, plus 2. All right, so then we already know what what a is. That gives this whole thing as minus 4. And b is minus 2, so that becomes plus 4, right? And then that means c equal to 2. C equal to 2. Okay, now let me check to make sure I didn't mess up. Yep, that's it. And with that, we are done. We have a is equal to 1. Okay, so we'll replace a with 1 in here. B is equal to minus 2, so we'll replace that. And then c is 2, so we'll replace c as 2. And that is our answer. I don't want to write it out again so that I can save some energy. Okay, so this problem wasn't as bad as I thought. They can get a lot worse. And so with that, let's move on to example 3. Now next, let's look at example 3 on page 730. Now this time we have a more complicated situation. We have this thing, and there's no factoring it. It would be different if this was a minus, okay? Then you can do minus 2 plus 1. When it's a plus, you're out of luck, okay? Because, yeah, it's just not going to end up being 1 when you have a 2 here. There's just no way to factor this without the quadratic formula, and we're not going to do any formula right now. So then, being that there's no way to factor it, then we need to pull a different trick. And the different trick is this: that this will go as we did before. Okay, this thing is going to be equal to sum a divided by x plus 3. So far, so good. Then what about this thing? This thing, it will decompose like this. It'll stay this way. That is, it's not going to break down anymore because there is no simple way to break it. And we're not going to use the quadratic formula and come up with a bunch of square roots. That's just not going to happen. We'll keep it like this. But however, up here, however, we need an x up here too. So the method is to do it like this, okay? bx plus c. That's about the only way that you can make this work. So once you have that, then we're going to solve for a, b, and c just like we did before. And when we do that, then the thing will come out. But with this thing not being factored, okay? And so if this is the situation where if your equation cannot be factored normally, then you have to pull this trick. So this trick is specific for those equations that cannot be factored. If it can be factored, then you can't do this. So let's, well, then now that we know that, let's write this out like we always do. What is this anyway? This will write out as, let's see, I'm going to rewrite this. So now we are going to play the same trick. That is, each thing up here will multiply the denominator that it doesn't have, so that we have so that both terms have the same denominator. So the numerator now becomes with this as the denominator. Okay, we're going to combine them, and so then we have a times the numerator becomes a times this stuff right here, x squared plus x plus 2. And then bx plus c, the whole thing will be multiplied by the stuff over there, plus bx plus c in parentheses times x plus 3. All right, now that's just the numerator, okay? The denominator is this thing times that, and I'm not going to write it so that I can save myself some energy. So now the numerator equals to this. The next step we have to do is the tedious work of multiplying it out and collecting terms and all that stuff. So this will become ax squared. Okay, we'll do all the x squared together. What is this? This is b. There's only one x squared in here. That's bx squared. So we'll write it down here. Bx squared. All right, that's x squared. Next, we have ax. Now I'm working on the x's. Ax, over here, what kind of x do we have? We have bx times 3, right? So which is 3bx. And then c times x plus cx. So those are the x's. And finally, we look at the constant terms. 8 will be multiplied by 2. So the constant terms consist of 2a. And then that's from there. And then the constants here consists of c times 3 plus 3c. And that should cover all of them because we only have x squared, x, and constant here. So unless I miss something, that should come out. But let me check to see if I missed something. Now at this point, we can say that a plus b has to be equal to 8, okay? And then matching coefficients up. A plus 3b plus c has to equal to 12, and then 2a plus 3c had better be equal to negative 20. However, the book says that we can pull a trick right here because this situation right here, we can choose a value of x to make this whole thing go to 0. Because this has to be equal no matter what x is, okay? So then let's choose, well, let's play that trick. Is that easier? I don't know, hard to say, but since the book's recommended, let's try it. Doesn't hurt to try. So let's let x equal to 3 in this equation, this thing right here, or expression right here, we'll call this thing 1, okay? So in 1, let x equal to 3. If that is the minus 3, sorry. See, minus 3. Then this will be 0, and this times that will be 0, and then we just have to calculate that. What does that give us? Okay, and that doesn't sound like a lot of fun to me, but oh well, I'll do it. So we have a times x is minus 3, okay? So a times 9 plus minus 3 plus 2 is going to be equal to the numerator up here, which is 8 times 9 plus 12 times negative 3 minus 20. See? I didn't think this trick looks like that good of a deal, but okay. But we should try it anyway, since the book mentions it. So let me get my calculator and let's punch this out. All right, I found my calculator, so let's do that. What is 9 minus 3 plus 2? That's 9 minus 1, that's 8. All right. And so we have to divide by 8, and the other side is 8 times, that's 72, 8 times 9, minus 36, and then, oops, I punched in the wrong things, 36, and then minus 20. And then, and I forgot to put in parentheses, so I need to go back and do that. All right. And then divided by, what did I say that was, 8? Let's see, e equals to 2. Okay, now let me check. So a equals to 2, but that doesn't seem like that easy of a way of getting it. Maybe we should have just done our original system. Doesn't matter. It's a good experience. So a equal to 2. So that is one trick you can pull if things look good to you. That is, say choosing x equal to minus 3 here will make this 0, which will knock out all this. But then you still have that to deal with, and that looks painful to me. But anyway, so we did that, and we figured out a equal to 2. And then the next thing we will do is we will do the next step, which is a plus b equals to 8, right? Right here. We have a plus b equals to 8, which means b had better be 6. Okay, so let me check that. Yep, that's right. B is 6. And then finally, we need something like 2a plus 3c equals to negative 20. So we'll write that down. 2a plus 3c equals to minus 20. And a was what? 2. So this is, so 3c equal to minus 20 and then minus 4, right? So that means c equals to 24 divided by 3 is negative 8. Is that right? Yep, that is correct. So now that we know that, we replace those numbers over here. A should be 2, B should be 8, and no, sorry, B is 6. B should be 6, and C is minus 8. If you replace it, then this whole thing will work out. And that is that is example 3. Next, let's look at example 4 on page 732. Now we have, pay attention to the denominator. Now we have x, and then we have 2 of these things that cannot be reduced. That's it. You can't factor what's in here. X, that is, things normally factor so that the second power goes down to just power 1, like x. But this one, it cannot be done, and yet there's 2 of them. Now to handle this, here's the trick. I mean, here's the rule that you follow, is that we will have a over just x, that's the first factor, and then we will have bx plus c will be over the second factor, just this thing though, x squared plus 1, one of them, see, no squared on the second case. And then we'll have another one, and then dx plus e. And with this, we're going to do the x squared. And that's the only way to make this thing happen. Squared. Okay. So now we need to, we have written that down. So in general, if you have an irreducible part on the bottom, you see, with x squared, then you need an x on top. So you have 2 terms on top. Whereas if you just have x to the power 1, then you just need a number, a. But this is x squared, so you need bx plus c. If this thing's being repeated, right, like this is repeated here, then you need another one, dx plus c over the squared, and bx plus c is over just the thing without the squared. So now we have 5 unknowns to solve, which is doesn't sound like much fun, I have to admit, but we have to do it just so that you learn how to do it. Okay, and once we learn this, we'll use the calculator to crank this out if you ever have to do this, and don't ever have to touch it again. But right now, let's do this. So this, to have this thing at all common denominator, then the numerator has to be, we'll write down the numerator, a has to be multiplied by, the denominator is this thing. We have, a will be multiplied by that, okay? So a times, let's see, x squared plus 1 squared And then, yeah, so because then, well, anyway, plus b x plus c, this will multiply by that and that, okay? Because it only has one of them, so it needs that and that together, times x and times x squared plus 1. All right, and then finally, the dx plus e, being it already has the squared, it only has to multiply by x. So dx plus e will be multiplied by x. All right, and now we will do the tedious work of multiplying this thing out. Now, to multiply this out, we have, well, there's no way around this except to just, you know, grit your teeth and do it. So we have a x, this is x squared will be x to the power 4th, okay, plus 2a x of x squared, and then plus 8. All right, and then next, this is, there's an extra x here, so we'll have bx times x squared, that's a bx cubed, and then another x will be x to the power 4th. And then bx times this one is equal to bx, and then another x make it bx squared. And then we're done with bx. Now next, cx, c is up. C times x squared is cx squared. But there's another x, so it becomes cx cubed. And finally, c times 1 is just c. But there's an x here, so it becomes cx. And then finally, we have dx, d, let's see, dx squared, and then, okay, plus ex. All right, so now we have something from the 4th power. Yeah, well, the book probably has some trick they want you to pull so that you can not do this as much. That trick doesn't seem to really help that much. Let me think. Should we do the trick? Nope, no trick this time. The book just wants to do it the old-fashioned way. All right, so what we get is, first let's focus on x to the power 4th. The coefficient is 1. So x to the power 4th means a plus b. That's it. So a plus b has to equal to 1. Right here. Next, the power 3. What's power 3? cx cubed. That's it. Right? I don't see anything else power 3. Okay, so that means c has to equal to 1. Power 3 has coefficient 1. And then power 2, x squared. X squared consists of 2a, and then any more x squared plus b, and then x squared plus d, and that equals to 1 also. All right, and then next, just x. Any x's? Right here, c, just x, c plus e equals to minus 1 from here. And finally, constant terms. There's a, yeah, a, and then I don't see anything else. I think that's it. A has to equal to 1. All right, so let me check to see if I got it right. So far, I have 2 of them correct. A is 1, C is 1, and both checks out. Okay, now that helps a lot, because if A is 1, that means B has to be 0 from this equation, right? Because A is 1. B has to be 0, so we got B also. And then C is 1, then 1 plus E equals to -1, which means E equals to -2. So we got that. So now we have, we only have D to worry about, which is right here. And from this equation, D works like 2A, which is 2, okay, plus B, what was B again? B is 0, so we don't have to do anything. plus D equals to 1. So that means D equals to minus 1. D equals to minus 1. So we got everything found. Now let me double check. Yep, all 5 answers found correct. See, A, B, C, D, and E. So that's what we're going to write down right here in the answer. A is going to be, what was A again? 1. So A will be replaced with 1. B is 0, so B is gone. C is also 1. And then D is, where's D? D is negative 1. And then E is negative 2. So that is the answer with all those horrible looking replacements. All right, so that is, I will finish this section in the next video.